there's a metal that doesn't melt. Well, technically it does, at 6,192 degrees Fahrenheit. For context, the surface of the sun is only 5 times hotter. You can't cast it, can't forge it like steel, can't even get it hot enough without the whole operation turning into a small-scale disaster. And yet, this same metal is inside every missile punching through the atmosphere at Mach 20. It's in your phone, your light bulbs, the drill bit that just cut through solid granite like warm butter. So, if you can't melt it, how the hell do you shape it? The geopolitical secret. Here's what they don't tell you about tungsten. China controls 80% of it. Not the mines, the refining, the knowledge, the infrastructure to turn raw ore into the powder that becomes unstoppable. During the Cold War, the Soviets didn't just want nukes. They wanted tungsten carbide drill bits, because you can't build an ICBM silo in Siberian permafrost without them. The US stockpiled tungsten like it was gold. Literally. Fort Knox-level vaults. Why? Because in 1950, we realized something terrifying. If you can't drill deep, you can't hide your missiles. If you can't machine rocket nozzles, you can't reach orbit. If you can't produce armor-piercing rounds, you lose wars. Tungsten isn't just a metal. It's leverage. The impossible problem. All right, let's say you've got a chunk of tungsten ore. Scheelite, wolframite, looks like dirty gravel. First problem, you gotta break the chemical bonds holding tungsten to oxygen. That requires hydrogen gas at 1,800 degrees Fahrenheit in a sealed furnace for hours. What you get isn't a solid ingot. It's powder, gray, fine as talc, each particle about 5 microns wide. And here's where it gets stupid difficult. You can't melt this powder into a solid block. The temperatures required would vaporize every known crucible material. Graphite, gone. Ceramic, crumbles. Even the heating elements would disintegrate before the tungsten softened. So they don't melt it. They squeeze it. The industrial alchemy. The process is called sintering. And it's basically controlled strangulation at the atomic level. Step 1. Mix tungsten powder with a binder, usually nickel or cobalt, just a few %. This is the glue. Step 2. Press it. We're talking 30 tons per square inch. Hydraulic presses the size of a 2-story building. The powder compacts into what's called a green body. It's fragile. You can crumble it with your hands. Step 3. The sintering furnace. You slide this green brick into an oven filled with hydrogen gas. No oxygen. Oxygen would ruin everything. Then you crank the heat to 2,500 degrees Fahrenheit. Not hot enough to melt tungsten, but hot enough to make the atoms migrate. They start bonding, fusing. The nickel melts and fills the microscopic gaps. The tungsten particles weld themselves together, atom by atom. 20 hours later, you pull out a solid block. Density? 19.3 grams per cubic centimeter, twice as dense as lead. You could hold a tungsten cube the size of a Rubik's Cube, and it'd weigh over 4 pounds. But we're not done, because here's the thing about sintered tungsten. It's hard. Like, scratch a diamond hard. Which means you can't machine it with normal tools. You need diamond-coated carbide bits. Coolant pumped at 100 pounds per square inch. CNC mills running at 0.002 inches per minute. One missile nose cone takes 60 hours of machine time. And if you mess up, you don't get a second chance. The part is scrap. 6 months of lid time. Gone. The hidden cost now. So, let's talk about what this costs, not money. Lives. Tungsten mines in China's Jiangxi province. Workers pull 12-hour shifts in tunnels where the air is 30% silica dust. No masks that actually work. Lung disease is just part of the job description. The refining plants? They dump ammonium paratungstate waste into rivers. It doesn't break down, doesn't dilute, just accumulates. Villagers downstream started showing kidney damage in the early 2000s. Nobody stopped production. And here's the kicker. Every smartphone has about 0.3 grams of tungsten in its vibration motor. Seems like nothing, right? Multiply that by 2 billion phones a year. We're using a metal that requires near-sun temperatures to process, and for a part that makes your phone buzz when you get a text. Hypersonic missiles. They're just the honest use case. At least we admit those are designed to destroy things.